Dear students, today we are going to see another example of simply supported beam with point loads. So already we have seen about simply supported beam with a single point load, double point load. Here we are going to see about simply supported beam with 3 point loads. So in all the problems, they will not give the diagrams directly. In some cases, they will give the beam and its loads in theoretical format. That is, a simply supported beam of span 16 meter, effective span carries the concentrated loads of 4 kilonewton, 5 kilonewton and 3 kilonewton at a distances of 3 meter, 7 meter and 10 meter respectively from left support. So for this, we have to draw the beam. If you draw the beam wrongly, the entire problem will be wrong. So we must be very careful while drawing the problem or beam from the theory. There is a question given in the question paper. So here a simply supported beam. So first thing is the beam is simply supported beam of 16 meter effective span. The span of the beam is 16 meter. We have to draw a simply supported beam of span 16 meter and carries concentrated loads. Concentrated loads means point load acting vertically downward direction 4 kilonewton, 5 kilonewton, 3 kilonewton. That means 3 point loads are acting. Where it is acting? At distances 3 meter, 7 meter, 10 meter respectively from the left support. That means the point load 4 kilonewton is acting 3 meter from the left support. The next 5 kilonewton is acting 7 meter from the left support. And the 3 kilonewton is acting 10 meter from the left support. That is first load 4 kilonewton is acting 3 meter and the second 5 kilonewton is acting 7 meter from the left support. That means between 4 kilonewton and 5 kilonewton, between these two loads, the distance is 4 meter. And the third load 3 kilonewton is acting 10 meter from the left support. So from left support, it is acting at 10 meter. So the remaining total 16 meter. So remaining is 6 meter. So we must be very careful while drawing the beam from the theory. Okay. So again I am repeating 16 meter beam carries 3 point loads. The first point load 4 kilonewton is acting 3 meter from the left support. The second point load 5 kilonewton is acting 7 meter from the left support. The third point load 3 kilonewton is acting 10 meter from the left support. For this case, we are going to find support reaction, shear force and bending moment, and finally we are going to draw the shear force diagram. How will you find the support reaction? By using equilibrium equation. So the first equation is summation h equal to 0. Since the beam has no horizontal force, so no need of using that equation. The second one is summation v equal to 0, that is sum of all the vertical forces in the beam is equal to 0. So simply supported beam, two supports, that means two reactions, that is upward reaction at A, upward reaction at B. So RA plus RB equal to total load on the beam, that is 4 plus 5 plus 3, that is 12 kilonewton. The third equation is summation m equal to 0. We have to take moment at A. Sum of moments of all the forces about point A is equal to 0. That is RB into 16. That will create a anti-clockwise moment, and rest of the beam, the rest of the loads will create a clockwise moment. That is RB into 16 is equal to 4 into 3 plus 5 into 7, where we are taking moment at A. 4 kilonewton is 3 meter from A, 5 kilonewton is 7 meter from A, 3 kilonewton is 10 meter from A. So you can see 4 into 3 plus 5 into 7 plus 3 into 10. So after substituting, after calculating this, we'll get the RB as 4.8125 kilonewton. RA, so already we have find RA plus RB equal to 12. So RA equal to 7.1875. How we can justify whether we have calculated these values correct or not? There is a shortcut is there. From A, 3 meter 4 kilonewton is acting. From B, 6 meter 3 kilonewton is acting. So near to A is heavy load is acting when compared with B. So distance is here is 3 meter. From A, 3 meter 4 kilonewton is acting. From B, 6 meter 3 kilonewton is acting. So A support A reaction should be more when compared with the support B reaction. So what we have got? 7.1875 at A, 4.8125 for B. So what we have calculated is logically correct. Next, we are going to find the shear force. So shear force at A. So at A, only reaction is acting. So shear force means algebraic sum of all the vertical forces either left or right side of the section. That means at which point we are going to find the shear force. We can take either left of the portion or right of the portion. Here I am taking left of the portion. Left of A, there is no beam. Only at the A point RA reaction is acting upward direction. That is plus 7.1875. At B, sorry, at C, the second point, that is 3 meter from A, the left portion is, in the left portion, RA is reaction is acting, and at this point 4 kilonewton also acting. So plus 7.1875 minus 4, that will give 3.1875. Again minus 5, that is minus 1.85 is adding. Again minus 3, that is 4.8125 is acting. Again plus 4.1825, that will come to the 0 point. You can see upward reaction, no force, downward force, no force, downward force, no force, downward force, no force, upward reaction. So already I have told that there are 3 lines only we are going to use in the shear force diagram. One is horizontal line, another one is vertical line, another one is inclined line. Vertical line is also, if the force is upward direction, the line should go from bottom to top. If the load is in downward direction, the line should go from top to bottom. As based on the direction of force, we can draw the shear force diagram. That is vertical line. And if there is no load between 2 points, there should be a horizontal line. If the beam carries a uniformly distributed load, we must use the, between 2 points, we must use the inclined line. Here we can see upward reaction between A and this point, no force. Again downward force, no force, downward force, no force, downward force, no force, upward reaction. You can see this point horizontal line, this point horizontal line, between this point horizontal line, between this point horizontal line. So all our conditions were satisfied. Okay, now coming to bending moment. Bending moment at A, that is x equal to 0. That is at the A point, left side of the A is no. The A point reaction RA is acting. So RA into 0. And at x equal to 3 meter, you can easily find RA into 3. That is 7.1875 into 3, 21.56. At x equal to 7 meter, RA into 7 minus 4 into 4. And that will give 33.93. At x equal to 10 meter, RA into 10 minus 4 into 7 minus 5 into 3. It gives 31.6875. So since the beam carries point load in the bending moment diagram, we have to connect all the points with the inclined line. So at A and B, the bending moment value is 0. So we connecting with the inclined lines in the bending moment diagram. You can see the maximum bending moment value is 33.94. So as already told, if the shear force value is 0, where the shear force value is 0, there the bending moment value will be maximum. And where the bending moment value is 0, there the shear force value will be maximum. You can see here. Here the at support A point, bending moment value is 0, but the shear force value is 7.1875. And also support B, bending moment value is 0. Here the shear force value is 4.8125. And here the shear force value is coming from plus to minus, that is crossing the 0 line. So at this point, that is 7 meter from A left support or 9 meter from right support, the shear force value is 0. That is shear force value is the shear force diagram. The shear force is crossing from positive to negative, that is crossing the 0 line. So there the bending moment value is maximum 33.9375. So hope you are all understand this problem. Thank you.